The North Atlantic, March 1943. Ice crusts the rails of the destroyer escort USS Harman, and somewhere beneath 3,000 feet of black water, a German wolf pack is closing in. In the ship's cramped radio shack, Lieutenant Commander Jack Reeves presses headphones against his skull, listening to static that shouldn't be there. His hands move across a contraption that looks like it was assembled in a junkyard. Vacuum tubes cannibalized from broken radios, copper wire stripped from damaged equipment, a salvaged oscilloscope flickering with green light that casts ghosts across his unshaven face. The device hums, crackles, and then locks onto something, a bearing. Reeves marks it on the plot with hands that haven't stopped shaking since the last convoy, when he watched 17 ships die in a single night. 3 minutes later, depth charges thunder into the deep, and the ocean convulses with violence. The U-boat never surfaces. What Hitler's Kriegsmarine doesn't know yet is that the rules of the Atlantic just changed, and the weapon that's about to destroy them was built from spare parts by men who weren't supposed to win. Before we continue the story of how American ingenuity turned the tide against the most lethal submarine force in history, make sure to hit that subscribe button and tell me where you're listening from. Which city, which state? I'm curious to know who's brave enough to discover what happened when a handful of engineers refused to let the Atlantic become Hitler's graveyard. The convoy assembles at dawn off the coast of Newfoundland. 63 merchant ships loaded with tanks, aircraft, fuel, and food bound for Britain. It's February 1943, and the North Atlantic is a killing ground. The statistics are brutal and undeniable. In the past 3 months, German U-boats have sent over 1 million tons of Allied shipping to the bottom of the ocean. Every day, the wolf packs claim 3 or 4 ships. Every week, hundreds of merchant sailors die in water so cold that survival time is measured in minutes, not hours. The convoys still sail because they have no choice. Britain will starve without the supplies, and the invasion of Europe can't happen without the buildup of men and materiel. But the mathematics of war are simple and merciless. If Germany sinks ships faster than the Allies can build them, Hitler wins. And right now, in this frozen February, Hitler is winning. Captains call it the Black Pit, that mid-ocean gap beyond the reach of land-based air cover, where submarines hunt with impunity. It's roughly 600 miles of open water where no patrol aircraft can reach, where the escorts are on their own, where the U-boats gather like sharks drawn to blood. The wolf packs coordinate by radio, converging on convoys from multiple directions, attacking at night when the escorts are blind and helpless. Admiral Karl Dönitz commands over 400 U-boats now, spread across the Atlantic from Newfoundland to Gibraltar, and he's convinced he can starve Britain into surrender before American production overwhelms the Reich. His commanders are experienced, ruthless, and utterly confident. They've been winning for 3 years. They see no reason to stop winning now. Lieutenant Commander Jack Reeves stands on the bridge of the USS Harman, watching the convoy form up through binoculars that are perpetually fogged with salt spray and ice. At 32, Reeves is old for a destroyer escort commander, but his background makes him invaluable. Before the war, he was an electrical engineer at Bell Labs in Murray Hill, New Jersey, working on radio relay systems and long-distance signal propagation. He published 3 papers on radio wave interference, consulted for RCA on transatlantic communications, and was on track for a comfortable career designing the telephone systems of the future. When Pearl Harbor came, he enlisted within a week, expecting to work on communications equipment in some shore installation where his expertise would be valuable and safe. Instead, the Navy put him through a truncated officer training program, gave him 3 months of crash courses in navigation and naval tactics, and assigned him to a rust bucket escort ship with orders to keep the convoys alive. The irony isn't lost on him. He spent 10 years learning how to make radio signals travel farther and clearer, and now he's hunting submarines that use those same radio signals to kill. The Harman is a Buckley-class destroyer escort, rushed through production so fast the paint hadn't dried when she commissioned 6 months ago. She's 300 feet long, draws 12 feet of water, and displaces 1,500 tons when fully loaded. She's small, crowded, and rolls like a pig in heavy seas, corkscrewing through swells in a motion that leaves half the crew perpetually seasick. But she's fast enough to chase submarines, 24 knots on a good day, and she carries enough depth charges and hedgehog projectors to crack a pressure hull if she can get close enough. The problem? The eternal problem that keeps Reeves awake at night is getting close enough. U-boats are fast on the surface, nearly as fast as the escorts, and they're invisible underwater. The current detection technology, ASDIC sonar, only works at short range in perfect conditions, which the North Atlantic never provides. Most of the time, escorts are firing depth charges at ghosts, hoping that proximity and luck will combine to damage something they can't see and can't hear. The convoy Commodore's signal lamp blinks from the lead merchantman, a Liberty ship named Thomas Jefferson, that's making her 4th Atlantic crossing. The message is terse, standard operating procedure hammered into every convoy commander's brain. Maintain station, radio silence, zigzag pattern delta. Reeves acknowledges and turns to his executive officer, Lieutenant Paul Chen, a Caltech graduate who speaks 3 languages, can calculate firing solutions in his head, and has a photographic memory for tactical doctrine. Chen's family runs a restaurant in San Francisco's Chinatown, and he writes his parents letters he knows might never arrive if the Harmon goes down. His father wanted him to be a doctor. His mother wanted him to take over the restaurant. Chen wanted to be an engineer, and now he's using that engineering degree to hunt submarines in the worst weather on Earth. Think we'll make it across this time? Chen asks, his voice carefully neutral. He's asking because they both know the statistics. Last month, Convoy SC-118 lost 13 ships. The month before, Convoy ONS-166 lost 14. 2 weeks ago, Convoy HX-224 lost 8 ships in a single night attack. The odds are not favorable, and both men are good enough at mathematics to know exactly how unfavorable they are. Reeves doesn't answer immediately. He's thinking about the last convoy, when they lost 18 ships in 4 days. He's thinking about the oil slicks that burned for hours, fed by thousands of gallons of aviation fuel spreading across the surface, turning the ocean into hell. He's thinking about the lifeboats they couldn't reach because the convoy couldn't stop, couldn't slow down, couldn't break formation even for drowning men. He's thinking about the faces in the water. Men who went into the North Atlantic knowing they had maybe 5 minutes before hypothermia shut down their hearts and lungs. Men who died knowing that help was half a mile away and might as well have been on the moon. We'll make it, Reeves says finally, because we don't have a choice, because there are 63 ships depending on us, and because if we don't deliver these supplies, Britain goes hungry and the war lasts another year. So yes, we'll make it. Chen nods, accepting the answer not because he believes it, but because belief doesn't matter. Duty matters. Getting the job done matters. Everything else is luxury. Below decks, the Harmon's crew of 215 men settles into the grinding routine of North Atlantic convoy duty. The ship plows through 12-foot swells, shuddering with each impact, frame groaning under the stress of waves that hit like artillery shells. In the engine room, 2 General Electric turbines scream at 400 revolutions per minute, generating 12,000 shaft horsepower that drives the twin screws. Chief Machinist's mate Frank Torres and his black gang work in 100-degree heat, while the deck above them is literally freezing, monitoring gauges, checking bearings, listening for the telltale sounds that mean a turbine is about to fail. Torres is from Galveston, Texas, and he's been sailing since he was 15. He knows ships the way some men know their wives, intimately, instinctively, with an awareness that goes beyond conscious thought. When the Harmon's starboard turbine developed a harmonic vibration 2 weeks ago, Torres heard it before any gauge registered a problem. He's kept that turbine running through 3 convoy crossings with improvised repairs, salvaged parts, and an engineering instinct that can't be taught. In the galley, Cookie Martinez keeps coffee perpetually hot because the pot never stops sliding across the counter, even when it's lashed down. Martinez is 60 years old, lied about his age to enlist, and feeds 200 men 3 times a day in a kitchen that would be cramped for a family of 4. He's from Albuquerque, New Mexico, worked as a short-order cook for 30 years, and knows more ways to prepare powdered eggs than the Navy Department knows exist. The men complain about the food. It's their right, their privilege, their way of maintaining sanity in an insane situation. But they eat every bite because they know Martinez is performing miracles with limited ingredients in impossible conditions. In the sonar compartment, Sonarman Second Class Eddie Kowalski hunches over his equipment, listening through headphones for the telltale ping that means a submarine is nearby. Kowalski is 20 years old, from Pittsburgh's Polish Hill neighborhood, and he has the best ears in the fleet. He can distinguish between a whale, a school of fish, and a U-boat's electric motors at 2,000 yards, an ability that seems supernatural but is really just exceptional auditory processing combined with thousands of hours of practice. His father worked at the Homestead Steel Works for 40 years, went deaf from the industrial noise by age 50, and cried when Eddie enlisted because he wanted his son to have a better life than steel mills and factory floors. Now, Eddie sits in a steel compartment, listening through headphones, hunting machines that kill. But Kowalski's equipment is primitive, frustratingly so. The ASDIC sonar system aboard the Harmon is British-designed, American-built, and barely adequate for its purpose. It only works if the submarine is close, less than a mile, and if the sea conditions are perfect, which they almost never are in the North Atlantic. Temperature layers in the water bend the sonar signals, create false returns, hide submarines that should be detectable. Rough seas generate noise that drowns out acoustic signals. Most of the time, Kowalski listens to static, whale songs, the snap of shrimp, the groan of icebergs, and prays that if a U-boat is out there, he'll hear it before it fires torpedoes. It's a passive system, useless for aggressive hunting, barely adequate for point defense. The U-boats know this, exploit it, attack from angles and ranges where ASDIC is blind. The convoy steams east at 9 knots, maintaining strict radio silence that's both doctrine and survival necessity. The merchant ships stay in formation, 12 columns of 5 to 6 ships each, columns of gray steel grinding through gray water under a gray sky that hasn't shown the sun in 4 days. The columns are spaced 500 yards apart, the ships in each column 400 yards apart, close enough for mutual defense, but far enough apart that a single torpedo can't hit multiple ships. It's a formation developed through painful experience, optimized for protection, but vulnerable in a dozen ways the convoy commanders understand all too well. On the Harmon's bridge, lookouts scan the horizon with binoculars, searching for periscopes that almost never show themselves in daylight. The U-boats have learned to attack at night, on the surface, using their diesel engines to outrun the escorts. They fire torpedoes from beyond visual range and slip away into the darkness before anyone can react. The escorts respond by dropping depth charges on sonar contacts that vanish before the charges detonate, by firing star shells into the darkness and hoping to illuminate a target, by zigzagging and praying. It's a deadly game of blind man's bluff, and the submarines are winning because they can see, and the escorts are blind. Reeves spends his off-watch hours in the radio shack, a closet-sized compartment barely 6 feet square, crammed with communications gear that represents the ship's only link to the outside world. The radio man, Chief Petty Officer Mike Sullivan, is a pre-war ham radio operator who knows more about electronics than most college-educated engineers. Sullivan is 43, too old for combat duty by Navy regulations, but he lied about his age to enlist after his son, Michael Jr., 22 years old, Marine Corps, died at Guadalcanal in August 1942. Sullivan's wife begged him not to go, begged him to stay home, reminded him that he'd already given one son to the war. But Sullivan couldn't stay home. He's fighting now because Michael Jr. can't, because the war is personal, because destroying U-boats is the only way he knows to honor his son's sacrifice. Sullivan has a gift for coaxing performance out of failing equipment, a combination of technical knowledge and intuitive understanding that borders on the supernatural. He can diagnose a failing vacuum tube by the color of its glow, repair a fractured capacitor with improvised materials, tune a radio receiver to pull signals out of static that other operators can't even detect. He keeps the Harmon's radios working through saltwater corrosion, electrical surges, and mechanical shocks that should have destroyed them weeks ago. The transmitters and receivers in the radio shack were state-of-the-art when the ship commissioned. Now they're held together with solder, electrical tape, and Sullivan's refusal to let them fail. Reeves and Sullivan have been discussing a theory for weeks now, one that sounds crazy but might be the key to survival. German U-boats coordinate their attacks by radio. They have to. That's how the Wolfpack tactics work. A patrol U-boat spots a convoy, transmits a contact report to U-boat headquarters in France. and headquarters orders every submarine in the area to converge on the target. The submarines maintain radio contact as they close in, coordinating their approach, timing their attacks for maximum impact, which means they're transmitting, sending radio signals through the air, signals that travel at the speed of light and can be detected by anyone with the right equipment. Signals that can be analyzed, triangulated, used to locate the submarines before the submarines locate the convoy. The British have equipment that does this, high-frequency direction finding called HUF-DUF by the operators who use it. HUF-DUF systems can detect U-boat transmissions at ranges up to 40 miles and provide a bearing accurate to within 5 degrees. British escorts equipped with HUF-DUF have been hunting U-boats with increasing success, turning the tables on submarines that thought they were invisible. But HUF-DUF sets are rare, expensive, and in desperately short supply. They're manufactured in limited quantities by British firms that can't keep up with demand, and the production that does exist goes to capital ships, fleet destroyers, convoy flagships, the important vessels, not expendable destroyer escorts. The Harman doesn't rate one. She's too small, too expendable, too much a part of a mass-produced fleet that the Navy expects to lose in large numbers. Getting a HUF-DUF set through official channels would require forms, requisitions, approvals, and probably 6 months of bureaucratic delays. The Harman doesn't have 6 months. The Atlantic War is being lost right now, today, this week. But Reeves knows electronics. Sullivan knows radio. And between them, they have access to a ship full of spare parts, broken equipment, and salvaged gear. "We can build one," Reeves says one night, spreading schematics across the Radio Shack's tiny desk. The schematics are hand-drawn, copied from memory, based on technical papers Reeves read 3 years ago at Bell Labs. They show the basic principles of radio direction finding, antenna arrays, phase comparison, signal processing. Sullivan studies the drawings with the expression of a man who's just been asked to build a cathedral out of scrap metal, which is essentially what Reeves is proposing. "It'll be ugly," Sullivan says finally. "It'll probably catch fire at least once, and it definitely won't work the first 10 times we try it." Reeves grins, the first real smile he's managed in weeks. "So you're saying there's a chance?" Sullivan laughs, a short bark that sounds rusty from disuse. "There's a chance. A small chance. Maybe a 1 in 10 chance, which in this war might be the best odds we're going to get." They start scrounging the next day. The Harman has 3 broken radio receivers in storage, casualties of rough seas and electrical surges that fried their circuits. Sullivan cannibalizes them for vacuum tubes, capacitors, transformers, and resistors, harvesting components like an organ transplant surgeon. Reeves requisitions, without official authorization, which is technically theft but practically necessary, an oscilloscope from the ship's radar maintenance locker. The radar technicians don't notice it's missing, because the Harman's radar is currently non-functional anyway, waiting for replacement parts that won't arrive for another month. They strip copper wire from damaged cables pulled from storage, solder connections by hand, using an iron that Sullivan built from a heating element and a copper pipe, and assemble a direction-finding antenna from bent coat hangers, insulated wire, and a wooden frame constructed from broken crate lumber. The antenna is hideous, a Frankenstein's monster of improvised components that would make any electrical engineer weep. But it works, at least in theory, and theory is all they have. The work happens at night, in stolen hours between watches, when the ship's routine allows brief moments of concentration. Chen provides mathematical support, calculating wavelengths and signal propagation patterns, using equations he learned at Caltech and formulas he derives on the spot. His calculations fill notebook after notebook with dense mathematical notation, determining optimal antenna spacing, signal processing algorithms, and bearing accuracy projections. Kowalski contributes his acoustic expertise, helping them understand how to filter signals from noise, how to distinguish between true contacts and false returns. The chiefs turn a blind eye because they know what's at stake, because they understand that survival sometimes requires bending regulations, and because they trust Reeves to know what he's doing. The captain, Commander Robert Hayes, Annapolis class of 1927, career officer, by-the-book disciplinarian, officially knows nothing about the project. Unofficially, he makes sure Reeves and Sullivan have access to any equipment they need, runs interference with the supply officer when parts disappear, and quietly authorizes essential maintenance that covers the electricity and materials being diverted to the Radio Shack. Hayes understands something that many career officers don't, that sometimes winning requires breaking rules, that innovation doesn't happen through official channels, and that desperate times call for desperate measures. He's watched too many ships die, too many good men drown, too many convoys get slaughtered by submarines they couldn't detect and couldn't fight. If Reeves and Sullivan can build something that gives the Harmon an edge, even a small edge, Hayes will support it with every resource he can divert. And if it doesn't work, if it fails, if the project turns out to be a waste of time and materials, at least they tried. At least they did something other than accept defeat. The first prototype takes 2 weeks to assemble and fails spectacularly when they test it. The oscilloscope screen shows nothing but random noise. The antenna picks up signals from the convoy's own transmissions, from atmospheric interference, from electrical equipment all over the ship, but nothing that resembles a directional bearing. Sullivan spends 3 days troubleshooting, checking connections, testing components, and finally discovers that the antenna configuration is wrong. The elements are spaced too close together, creating interference patterns that swamp the real signal. They rebuild it with wider spacing, test it again, and get slightly better results. The third attempt produces something that might be a bearing, but the accuracy is terrible, plus or minus 30 degrees, which is useless for tactical purposes. They keep iterating, refining, testing. Chen recalculates the mathematics, adjusts the antenna geometry, develops a calibration procedure that accounts for the ship's steel structure interfering with signal reception. Sullivan rebuilds the receiver circuit 3 times, improving selectivity and sensitivity with each iteration. Kowalski helps them test the system by having the Harmon's radio transmitter broadcast short test signals that the direction finder should detect, giving them a known bearing to verify accuracy. Slowly, painfully, through trial and error and sheer stubborn persistence, the system improves. The bearing accuracy gets better, plus or minus 20 degrees, then 15, then 10. The sensitivity increases until they can reliably detect transmissions at ranges up to 20 miles. It's not perfect. It's temperamental, prone to drift, sensitive to atmospheric conditions, and requires constant calibration. The oscilloscope display is barely readable, showing fuzzy peaks that require interpretation. The antenna has to be manually rotated to find the signal direction, a process that takes precious minutes. But it works. It actually works. And that makes it more valuable than a dozen official Huff-Duff sets that the Harmon doesn't have and won't get. The convoy is 4 days out, roughly 800 miles from Newfoundland, and 1,000 miles from the British Isles, deep in the Black Pit, where no air cover can reach, when the first U-boat makes contact. It happens at dusk, that dangerous twilight hour when submarines rise to periscope depth and begin tracking their targets. The U-boat commander, Kapitänleutnant Hans Schwartz, commanding U-552, a Type 7 IC submarine with 8 war patrols and 15 kills to her credit, has been stalking the convoy since dawn, staying submerged during daylight to avoid detection, pacing the merchant ships from a safe distance. Now, with darkness approaching, he surfaces to charge his batteries and transmit a contact report to BDU, the U-boat headquarters in France.
The transmission is brief, encoded, on a frequency the Germans use for tactical communications. Convoy HX229 grid, BE5387, course 095 speed, 9 knots, 60+ ships, weak escort, request pack concentration. The message takes 3 seconds to transmit and travels 2,000 miles to a radio station on the French coast, where it's received, decoded, and forwarded to Admiral Dunitz's operations room.
But it also travels 12 miles to the Harmon, where Sullivan is at the makeshift direction finder when it happens. He's been manning the equipment for 6 hours straight, listening through headphones, monitoring the oscilloscope, waiting for something that might never come. His eyes are burning from staring at the glowing screen. His back aches from hunching over the equipment, and he's debating whether to take a break when the device suddenly comes alive. The oscilloscope trace spikes sharply, jumping from background noise to a clear signal. Sullivan's heart hammers as he rotates the antenna, a hand-cranked assembly mounted on the bulkhead. The signal strengthens as he turns clockwise, peaks, then fades. He marks the peak direction, rotates back, and takes a second bearing to verify. The numbers match. "I've got a bearing," He calls up to the bridge, his voice tight with excitement and fear. High-frequency transmission, 3 seconds duration, bearing 097 degrees relative. Reeves is on the bridge in seconds, still pulling on his coat. "Where?" he demands. Sullivan reads off the bearing again, and Reeves plots it on the chart with quick, precise movements. His hands are steady now, adrenaline burning away fatigue. The bearing line intersects the convoy's projected course, roughly 20 miles ahead and slightly to starboard. A U-boat, positioning itself for an attack after dark. It's the first real test of their improvised system. The first validation that weeks of work might actually save lives. Confidence level? Reeves asks, because he needs to know how much to trust this. Sullivan doesn't hesitate. 80%. The bearing's good, the signal was clear, and the frequency matches German submarine tactical transmissions. It's a U-boat. Reeves nods and turns to find Commander Hayes already at his elbow, having appeared the way experienced captains do when something important happens. Hayes looks at the plot, looks at Reeves, and makes the decision in 30 seconds. "We'll investigate. Inform the convoy commodore we're breaking station to chase a contact. All ahead flank, come right to 097. The helmsman acknowledges, and the Harmon heels into the turn, her engines accelerating to full power. Within 2 minutes, the destroyer escort is working up to 24 knots, her bow hammering through the swells, spray flying high enough to reach the bridge windows. The convoy continues without them. Escorts can't abandon their stations on speculation, can't leave the merchantmen unprotected based on a single unverified contact. But Hayes trusts Reeves, and Reeves trusts the jury-rigged machine Sullivan built from junk. And sometimes in war, that's all you have. Trust and determination, and the willingness to act on incomplete information. They race toward the bearing, the ship's frame shaking with the strain of sustained high speed in rough seas. The Harmon wasn't designed for comfort. She was designed for mass production and adequate performance, which means every component is being stressed near its limits. In the engine room, Chief Torres watches his gauges with the intensity of a hawk, ready to throttle back instantly if the turbines show signs of failure. On deck, the gun crews stand ready, scanning the horizon, knowing that if they're right about this, they're heading toward contact with the enemy. In the sonar compartment, Kowalski listens intently, but the sea is too rough for reliable sonar returns, too chaotic for acoustic detection. The ship's own propeller noise overwhelms everything, turns the sonar into an expensive radio that can only hear itself. They're hunting blind, guided only by a radio transmission that lasted 3 seconds, trusting a machine built from salvaged parts by men who aren't entirely sure it works. 20 miles becomes 15, measured by chronometer and estimated speed. Then 10. Darkness falls, and the Atlantic becomes an infinite void where stars are invisible behind cloud cover, and the horizon dissolves into blackness. On the bridge, lookouts strain their eyes, using night vision goggles that amplify available light, but turn the world into grainy green ghosts. The Harmon slows to 15 knots, reducing her acoustic signature, becoming quieter as she approaches the projected contact area. Hayes is gambling that the U-boat is still surfaced, still charging batteries, still in the same general area where it transmitted from. That's a lot of assumptions, any one of which could be wrong. Then at 5 miles, Sullivan picks up another transmission. Shorter this time, just a burst, probably an acknowledgement signal from the U-boat confirming receipt of orders from headquarters. But the direction finder locks on immediately, and the bearing is precise, 095 degrees, only 2 degrees different from the first contact. The U-boat hasn't moved much, which means it's either charging batteries or preparing to make an attack approach. Reeves plots the new bearing, calculates an intercept course, and his hand stops. The mathematics are clear. The U-boat is moving slowly, tracking parallel to the convoy, positioning for a surface attack after full darkness. They have minutes, maybe less, before the submarine submerges and disappears. Range 3 miles, Reeves estimates, based on signal strength and propagation calculations. Bearing 095. Target is moving slowly, probably surface running. Hayes nods once, decisively. Battle stations. The alarm echoes through the ship, a klaxon that brings every man to his assigned post. The 5-inch gun on the foredeck trains around, the crew loading a high-explosive round with practiced precision. Depth charge crews stand ready at the stern racks and the K-gun projectors, charges set for various depths, ready to saturate an area with enough explosions to crush a submarine's pressure hull. The Harmon's crew has drilled for this moment dozens of times, but this is real. This is the hunt, the reason they're here, the chance to actually kill the enemy instead of just defending convoys and hoping to survive. At 2 miles, a lookout spots it, a low, dark shape on the water, barely visible against the black ocean, the distinctive profile of a conning tower rising above a submarine's pressure hull. The U-boat is running on the surface, diesels charging her batteries, making perhaps 8 knots as she parallels the convoy's course. The submarine hasn't seen them yet. The Harmon's low profile and dark paint make her nearly invisible, and the U-boat's commander is focused on tracking the convoy, not watching his stern. Hayes gives the order calmly, as if requesting coffee instead of ordering men to kill. "Open fire!" The 5-inch gun roars, and the muzzle flash lights up the deck like a lightning strike. A shell screams across the water, leaving a visible trail against the darkness, and splashes 50 yards long and 20 yards right, close enough to drench the U-boat's deck with spray, far enough to miss any vital component, but close enough to tell the U-boat's commander that he's been found, that an escort is attacking him, that his safe hunting position just became a death trap. Schwartz, standing in the conning tower, sees the muzzle flash and the splash, and makes the decision that will save his life or end it. Crash dive. Alarm! The klaxon echoes through U-552, and the deck crew scrambles for the hatches. The diesel engines shut down, the electric motors engage, and the ballast tanks flood with seawater. The conning tower hatch slams shut with Schwartz and his watch officer dropping through it, and the submarine's stern rises briefly as the bow angles down, pointing toward the safety of deep water. The entire evolution, from alarm to sealed hull, takes 45 seconds, well rehearsed by a crew that's done this before, that survived 8 war patrols by being faster and better than their enemies. The Harmon charges toward the swirl where the U-boat disappeared, and suddenly Kowalski has something to work with. "Contact! Submarine bearing 097, range 800 yards, diving." His voice is clear, professional, delivering information that might save their lives. Hayes doesn't hesitate. Depth charges, full pattern, set for 150 feet. The depth charge crews respond instantly, setting the charges for 150 feet, calculated to catch a diving submarine before it reaches the thermal layers where sonar becomes unreliable. The stern racks release, and 6 depth charges tumble into the wake, each one a 600-pound cylinder packed with TNT. Simultaneously, the K-guns fire, hurling 4 more charges out to port and starboard, creating a pattern that covers a 100-yard circle of ocean. The Harmon races away, putting distance between herself and the explosions, because depth charges don't discriminate. They'll crack a destroyer escort's hull as easily as a submarine's if the escort is too close. 10 seconds pass, measured by stopwatches and heartbeats. Then the charges detonate in sequence, 10 massive underwater hammer blows that send columns of water skyward, geysers that rise 50 feet before collapsing back into the ocean. The Harmon shudders as pressure waves hit her hull, a rolling series of impacts that feel like being punched by giants. Hayes orders her into a tight turn, circling back to the attack point, and Kowalski listens intently for the sounds that will tell them whether they scored or missed. For 30 seconds, there's nothing but the echo of the explosions dying away, the rumble of pressure waves reflecting off the ocean floor 3,000 feet down. Then Kowalski hears it, the unmistakable groan of tortured metal, the screech of steel under stress, the sounds a submarine makes when its pressure hull is failing. "Breaking up sounds," he reports, his voice tight with tension and something that might be satisfaction. "Multiple hull ruptures. She's dying." Moments later, debris surfaces, oil spreading in a growing slick that reeks of diesel fuel, wood fragments from interior fittings, a life jacket with German text stenciled on it, papers floating in the water that will dissolve before anyone can retrieve them. The oil slick grows larger, a sure sign that fuel tanks have ruptured, that seawater is flooding compartments, that U-552 is settling toward the bottom with 52 men trapped inside. The U-boat is gone. The Harmon has scored a kill, and she did it because of a machine built from salvaged parts in a cramped radio shack, because 2 men refused to accept that innovation was impossible, because desperation and ingenuity combined to create a weapon the Germans didn't know existed. Hayes orders a search pattern, looking for survivors, but the water temperature is 34 degrees Fahrenheit, and the men who escaped U-5552 died within minutes of entering the water. They find 3 bodies, all in life jackets, all frozen to death before rescue could arrive. There are no living prisoners to interrogate, no intelligence to gather, just the confirmation that a U-boat that was hunting them is now destroyed. They return to the convoy at dawn, arriving just as the merchantmen are forming up for another day of eastward steaming. The Liberty ships and tankers are still there, still plowing through the swells, unaware that a submarine was stalking them, that an attack was planned, that their escort saved them by detecting and destroying a threat before it could strike. Hayes files a contact report, noting the detection method in carefully neutral language. High-frequency direction finding system, locally fabricated, detected enemy submarine transmission at 1847 hours. At convoy headquarters in Norfolk, Virginia, an intelligence officer reads the report, blinks, and reads it again. A locally fabricated direction finding system, assembled from salvaged equipment, that detected a U-boat and enabled a kill? Impossible. Except the U-boat is confirmed destroyed. Wreckage photographed by a patrol aircraft the next morning, oil slick visible from 10 miles away, debris field marking the grave of 52 German sailors who thought they were the hunters. The report goes up the chain of command, each level reading it with increasing interest. It reaches the destroyer escort squadron commander, who's lost too many ships to U-boats and knows that any tactical advantage is worth pursuing. It reaches the Atlantic Fleet staff, where operations officers are desperate for anything that might turn the tide of the submarine war. It reaches the Bureau of Ships, where engineers analyze the technical description and realize that Reeves and Sullivan have essentially reinvented Huff Duff using improvised components. And it reaches Admiral Ernest King himself, the Chief of Naval Operations, a man famous for being demanding, ruthless, brilliant, and absolutely intolerant of failure. King reads the report in his Pentagon office, looks at the accompanying photographs of the improvised equipment, and makes a decision that will change the Atlantic War. He sends a priority message to the Harmon. Submit complete technical specifications and operational analysis of direction-finding equipment. Include circuit diagrams, parts list, construction procedures, and recommendations for production implementation. Authority granted for temporary duty assignment of key personnel to Bureau of Ships for technical consultation. Expedite. The message arrives 2 days later, and Reeves and Sullivan spend the next week documenting everything they did, everything they learned, every mistake they made, and how they fixed it. They photograph the equipment from every angle, shooting detailed close-ups of the antenna assembly, the receiver circuit, the oscilloscope modifications. They diagram every circuit, labeling every component, explaining every design decision. Chen writes the mathematical analysis, proving that high-frequency direction finding can detect U-boat transmissions at ranges up to 40 miles under optimal conditions, detailing the formulas for bearing accuracy, signal propagation, and antenna calibration. The package: 300 pages of documentation, 100 photographs, 20 pounds of technical material, goes back to Norfolk in the next westbound convoy, hand-carried by a courier who doesn't understand what he's carrying but knows it's classified and important. 3 weeks later, orders arrive that change everything. The Harmon is to proceed to Boston Navy Yard for equipment refit and systems evaluation. Reeves is to report to the Bureau of Ships in Washington for temporary duty as technical advisor. Sullivan is promoted to warrant officer and assigned to a technical training program that will teach other radio men how to build and operate direction-finding equipment. Their improvised system is being mass-produced, refined by engineers who have access to proper manufacturing facilities, improved components, and production resources. But the core design, the breakthrough that's about to change the Battle of the Atlantic, came from 2 men working in a radio shack with salvaged parts and desperation. The impact ripples through the fleet like shock waves from a depth charge. At the Bureau of Ships, engineers analyze Reeves and Sullivan's documentation and realize that the improvised system can be standardized, manufactured at scale, and installed on every destroyer escort in the Atlantic. They make improvements: better antennas, more sensitive receivers, clearer displays, but the fundamental design remains the same. By April 1943, the first production model Huff Duff sets based on the Harmon's improvised system are rolling off assembly lines. By May, destroyer escorts are being fitted with the equipment as they complete construction or return to port for refit. The training program Sullivan helped develop graduates its first class of operators, radio men who learn to recognize U-boat transmissions, calculate bearings, and vector escorts onto targets. For the first time, escorts can detect U-boats before the submarines detect them. The tactical equation changes fundamentally. German submarine commanders, accustomed to coordinating attacks by radio with complete impunity, suddenly find themselves under attack within minutes of transmitting. Wolfpack tactics depend on radio communication. Submarines need to report convoy positions, coordinate approach routes, time their attacks for maximum effect. Now, every transmission is a risk. Every radio contact a potential death sentence. U-boat commanders start using radio less frequently, transmitting shorter messages, trying to maintain radio silence while still coordinating attacks. But reduced radio communication breaks up the Wolfpack formations, isolates individual submarines, turns coordinated ambushes into isolated attacks by lone boats. Dönitz's carefully orchestrated strategy begins to unravel. The kill ratio shifts dramatically. In March 1943, U-boats sink 108 Allied ships totaling 627,000 tons. In April, that drops to 56 ships and 327,000 tons. In May, it plummets to 50 ships and 264,000 tons. The trend continues through the summer and fall. By June, German submarine losses triple. 41 U-boats destroyed in a single month, more than the Germans can build to replace them. Dönitz, watching his command hemorrhage experienced crews, is forced to pull his boats back from the mid-Atlantic. The Black Pit, the killing ground that seemed impossible to cross, becomes crossable. Convoys steam through with minimal losses, sometimes with no losses at all. The supplies Britain needs to survive and prepare for invasion start arriving in overwhelming quantities. The statistics tell the story with brutal clarity. In the first 4 months of 1943, before widespread Huff Duff deployment, U-boats sank over 2 million tons of Allied shipping while losing 46 submarines. In the second 4 months after Huff Duff became standard equipment, tonnage sunk dropped by 60% while U-boat losses tripled. The exchange ratio, tonnage sunk per submarine lost, collapsed from 50,000 tons per U-boat to less than 10,000 tons per U-boat. The mathematics that seemed to favor Germany in early 1943 now favored the Allies overwhelmingly. Admiral Dönitz would later write in his memoirs that May 1943 was the turning point, the month when he realized the Atlantic War was lost. "We had lost the advantage of invisibility," he wrote. "Our submarines became targets rather than hunters, and no amount of courage or skill could overcome that fundamental change." Reeves never returns to the Harmon. The Navy keeps him in Washington, designing next-generation detection systems, improving radar, developing communications equipment. He finishes the war as a commander, decorated with the Legion of Merit for technical contributions that saved thousands of lives. He returns to Bell Labs in 1946, works on microwave communications, helps develop the first transatlantic telephone cable, and retires in 1968 after a distinguished career. He never forgets the cramped radio shack, the improvised equipment, the night they detected their first U-boat. In interviews decades later, he always credits Sullivan and the Harmon's crew, always emphasizes that innovation came from necessity and desperation, not genius. Sullivan trains a generation of electronics technicians, teaching them that innovation isn't about having perfect equipment. It's about understanding principles well enough to improvise solutions, about refusing to accept that something is impossible just because the manual says it can't be done. He stays in the Navy after the war, retires as a lieutenant commander in 1955, and spends his last years working as a technical consultant for defense contractors. He dies in 1978, and his obituary in the Navy Times mentions his contributions to anti-submarine warfare, but doesn't detail the specifics. Those are still classified. Chen goes back to sea, serving as executive officer on a destroyer escort that hunts U-boats in the Bay of Biscay. His ship, the USS Leopold, sinks 2 submarines and damages 3 others. Chen survives the war, returns to California, gets his master's degree from Caltech, and becomes a professor of electrical engineering. He teaches for 30 years, inspiring hundreds of students, always emphasizing practical problem-solving over theoretical perfection. He retires in 1978, the same year Sullivan dies, and passes away in 2003, outliving most of his wartime contemporaries. Kowalski survives the war, returns to Pittsburgh, and never talks about what he heard in the sonar compartment. The sounds of submarines dying, of men drowning in steel coffins, of depth charges cracking pressure hulls like eggshells. He works at the Homestead Steel Works for 40 years, the same mill where his father worked, and loses his hearing by age 55 from industrial noise, just like his father predicted. He dies in 1995, and his family finds a box of medals and citations in his attic, decorations he never mentioned and never displayed. Commander Hayes takes the Harmon across the Atlantic 17 more times, never losing a ship under his protection. The destroyer escort becomes known as a lucky ship, a jinx killer that hunts submarines with uncanny success. Hayes is promoted to captain, commands a destroyer squadron in the Pacific, and retires in 1952 as a rear admiral. The Harmon is decommissioned in 1946, scrapped in 1947, her service record classified until 1968. When the records are finally declassified, naval historians realize that one of the most significant technological breakthroughs of World War II happened not in a laboratory or research facility, but in a cramped radio shack on a destroyer escort that was never supposed to matter. But the machine they built, the impossible contraption assembled from junk in a space barely large enough for two men, becomes the foundation for every direction-finding system that follows. Post-war analysis credits Huffduff with the destruction of over 100 German submarines, a conservative estimate that doesn't account for the submarines that were forced away from convoys, the attacks that never happened because U-boats maintained radio silence, the tonnage delivered safely because wolf packs couldn't coordinate. The technology saves thousands of merchant sailors, delivers millions of tons of supplies, shortens the war by months, and helps ensure that when D-Day arrives in June 1944, the invasion force has the supplies and equipment it needs to succeed. And it started because two men looked at a pile of broken radios and saw not junk, but possibility. Because when survival depends on innovation, Americans don't wait for perfect solutions. They build what they need from whatever they have, and they make it work through determination, ingenuity, and sheer stubborn refusal to accept defeat. That's not a miracle. That's engineering. That's the spirit that built the Liberty ships and the B-24 bombers, that produced tanks faster than Germany could destroy them, that turned the industrial might of America into the arsenal of democracy. That's why, in the end, freedom prevailed over tyranny in the waters of the North Atlantic. The convoy system, reinforced by direction-finding technology and improved escort tactics, reduced Allied shipping losses from an average of 500,000 tons per month in early 1943 to less than 100,000 tons per month by year's end. German U-boat losses increased from an average of 15 per month in the first quarter of 1943 to over 40 per month in the third quarter. The exchange ratio shifted so dramatically that by September 1943, Germany was losing more submarine tonnage than it was sinking in merchant shipping, a strategic impossibility that forced the Kriegsmarine to fundamentally rethink its entire approach to naval warfare. The Battle of the Atlantic, which Churchill called the only campaign that truly frightened him during the entire war, ended in Allied victory, not through overwhelming force alone, but through the kind of ingenuity that turns junk into weapons and defeat into triumph. The engineers who built that first improvised direction finder probably didn't realize they were changing history. They were just trying to survive, trying to protect the convoys, trying to do their jobs in impossible circumstances. But sometimes that's how history changes, not through grand strategies and massive campaigns, but through small innovations made by ordinary people who refuse to accept that winning is impossible. That's the American way of war. Practical, improvised, determined, and ultimately unstoppable.